All right. Let's dive into this deep dive all about object-oriented programming. You sent in some notes on OOP.
Ah, yeah.
And we're going to unpack it all.
Cool.
No need to sift through pages of technical stuff. We've got all the good stuff right here, ready to go.
You know, one thing I find really interesting is that a lot of people think OOP is this, like, really new thing.
Okay.
It's a really new and complex thing. But really, it's been around for decades.
Oh, wow.
Like, since the 1960s.
Yeah.
It's just about, well, you know, organizing your code in a way that kind of mirrors the way we think about the world.
Oh, interesting. So instead of actions, we're thinking about the things.
Yeah.
The objects that are doing the actions.
Yeah. Think of it like you're building with Legos.
Okay.
You know, like those little plastic bricks. You're essentially, as a programmer, you're creating reusable blocks of code, but each one has its own little purpose, its own ability.
Oh, neat. So you could have one that sorts all the numbers.
Right. Exactly.
Yeah.
So imagine you need to sort a list of numbers in your code. Instead of writing the whole sorting code every single time,
Right.
you could just create like a little sorter object that knows how to sort. And then anytime you need to sort something else, you can just reuse that sorter.
So it saves you tons of time and effort, it sounds like.
Exactly. That's the beauty of it.
My notes also mentioned that reusability, it also highlights flexibility and security as being really appealing aspects of OOP.
Right.
What makes it more secure?
So that comes down to this idea of encapsulation.
Encapsulation. Okay.
Yeah. So with OOP, you can take data and the methods that work on that data and kind of bundle them together, you know, within an object. And that actually makes it way harder for like outside code to just like accidentally mess things up. Think of it like a safe with a combination lock. Only the code that knows the right combination, you know, can get in there and actually change anything.
That's a good analogy.
It is.
But my notes also mention some downsides.
Yeah, of course.
It sounds like it might not be the best fit for every single project out there.
That's right. Like any powerful tool, it has trade-offs, right?
Okay.
And, you know, one thing is that the learning curve can be kind of steep.
For beginners.
Yeah, especially for beginners. You know, it's like you wouldn't hand someone a chainsaw if they've never used a saw before.
Definitely not. Definitely not. So when is it time to bring out the big OOP chainsaw?
Good question. When you're dealing with those large, complex projects that have a lot of moving parts, lots of interacting parts, you know, that's where OOP can really shine.
Okay.
Think of like a massive, you know, online video game.
Yeah.
Where you've got thousands of players, you've got items, you've got different environments.
Yeah.
OOP can make managing all of that way easier.
Oh, yeah, for sure.
And if you need to add a new feature or change something, you're way less likely to break the entire game.
Oh.
Because everything is a little self-contained.
Right. But also, my notes say that OOP can be a resource hog.
It can.
Especially when it comes to memory usage.
That's true.
Is that something to be concerned about?
It is a valid concern. It can require, more memory and more processing power than other approaches, especially if it's not done carefully. You wouldn't build, a simple calculator app with a framework designed for a massive multiplayer game. That just wouldn't make sense.
That's true.
It would be like, using a bulldozer to plant a flower.
Right. The right tool for the job. Speaking of tools, we've got to talk about the 4 pillars of OOP.
Yeah, the 4 pillars.
Yeah, when I first saw that, I imagined some ancient Greek temple.
It does sound very dramatic, doesn't it?
It really does, yeah. So what are these mysterious pillars?
They're the 4 core principles of OOP. Abstraction, encapsulation, inheritance, and polymorphism.
Oh.
Those are the big ones.
All right, let's start with abstraction. My notes say that it's about focusing on what an object does, not necessarily the how it does it. Can you make that a bit more concrete?
Sure. Think about driving a car. You don't need to know, everything about how the engine works or the transmission, all the intricate details.
Right.
You interact with the car through its interface, the steering wheel, the pedals, the gear shift. Abstraction and programming is kind of similar. It allows you to use an object without having to understand all the nitty-gritty details of how it actually works.
So it's like a user manual for your code?
Kind of, yeah.
Yeah.
Like a simplified user manual.
I like that.
It just tells you what you need to know to use it.
That makes sense.
Yeah.
What about encapsulation? What was that all about? I remember something about protecting data.
Exactly. It's about bundling data and the methods that operate on that data together.
Okay.
Remember that. Safe with the combination lock.
Yeah.
It's kind of like that. Only certain parts of the code have the right methods the combination, so to speak, to actually get in there and change anything. And that's how we keep things organized and secure.
Now on to inheritance. My notes mention a very amusing story about kangaroos and a flight simulator.
Oh, yeah, the infamous kangaroo incident.
What happened there?
It's a classic example of inheritance, but also a reminder that even with inheritance, you got to plan carefully. So these developers were adding wildlife to this military helicopter flight simulator.
Okay, to make it more realistic.
Yeah, exactly. To make the training more realistic, right? So they added kangaroos, among other animals. The problem was the kangaroo code, the kangaroo class, inherited from the soldier class.
Oh no, so the kangaroos were armed.
Yes. And the developer forgot to override the part of the code that handled weapons. So you can imagine what happened when the pilot in the simulator encountered these, weapon-wielding kangaroos.
Oh my goodness, that's hilarious.
It was a little chaotic, to say the least.
Poor misunderstood kangaroos. They probably just wanted to hop around. But I can see why that's such a classic example. It really does highlight the importance of understanding how inheritance works and really thinking it through.
It does, it does.
What about polymorphism? This last one, it sounds like a very complicated word.
Yeah, it's a mouthful, isn't it? But it's not as complicated as it sounds.
Okay, good.
Think about a simple command like play.
Okay.
In a music player app, play would start the music, right?
Mm.
But in a video game, play might launch a new level.
Okay.
Same command, play, but it triggers a different action.
Depending on what object it's attached to.
Exactly. Polymorphism gives objects that flexibility to respond differently to the same commands.
That's right. It's all about responding in a way that's appropriate for their type. So a music player object responds to play by playing music, and a game level object responds to play by starting the game.
Wow, that's pretty cool.
Yeah.
I'm really starting to see these four pillars actually work together.
They do, they do.
We've really covered a lot of ground here.
We have.
We've talked about what OOP is. We've talked about how it works. We've looked at those four core principles.
Yeah.
But there's still so much more to explore.
There is. This is just the tip of the iceberg.
Before we go too deep into the four pillars of OOP, those four principles, I think it's worth revisiting that car analogy.
Okay.
We talked about how you don't need to be a mechanic to drive a car.
Right.
It really illustrates that concept of encapsulation.
Yeah, okay. I'm with you so far.
Which is one of those key OOP principles.
Okay.
So how does that relate to actual programming?
Yeah, it feels kind of abstract to me, I have to admit.
It is. But it's all about hiding complexity.
Oh, okay.
So when you're driving a car, you're interacting with it through a very, very simple interface.
Yeah.
The steering wheel,
Yeah.
pedals, gear shift. You don't need to know how the engine works or the transmission or the brakes.
Right. I don't
All those little details.
Yeah.
But you can still make the car go right.
Yeah.
Encapsulation and code does the same thing. It bundles the data and the methods together inside that object, and then it provides a nice clean interface for interacting with that object.
Okay, so it's like we're giving our code a nice dashboard.
Yeah, exactly.
So
right.
it's user-friendly.
Yeah, exactly. A user-friendly dashboard.
Okay, great. Now, how about polymorphism?
Polymorphism.
We talked about the play command and how it can act differently if it's in a music player app versus a video game.
Right.
So can we see what that might look like in actual code?
Sure, absolutely. Let's say you're building a music player app.
Okay.
And you've got a music track object
Okay.
with the song title, the artist, the file location,
Right.
all that good stuff.
Okay.
That object would have a play method,
Oh, okay.
which when called starts playing the music. Right.
So I press play on the app and the music starts.
Exactly.
Right.
But now imagine you're also building a video game
Okay.
and you have a game level object
Right.
that stores information about, the layouts, all that good stuff.
Yeah.
This object could also have a play method,
All right.
but this one, when called, would load the level and start the game.
Okay, so play does completely different things depending on where it is.
Exactly.
That's pretty neat.
That's polymorphism in action,
Right.
The same word, play,
Yeah.
different actions based on the object.
Cool. So it adds a lot of flexibility.
It does.
Now, how about inheritance?
Okay, inheritance.
We had a good laugh with that kangaroo incident.
We did.
But where does inheritance actually get used effectively in the real world?
Okay, so think about, let's say, a banking system.
Okay, interesting.
You can have a base class, like an account class,
Okay.
And that would have common properties like, the account number, the balance.
All the stuff that every bank account has.
Exactly.
Yeah.
Exactly. But then you could have subclasses.
Right.
Like, a checking account.
Okay.
And a savings account.
Right.
That would inherit all those basic properties from that account class.
So you don't have to rewrite all that.
You don't. You get them for free.
That's awesome.
Right. But then each subclass can also have its own, unique properties and methods.
Mm-hmm.
So, for example, the checking account might have a write check method.
Right.
But the savings account might have, a calculate interest method.
That's a great example. It shows how inheritance lets you build that hierarchy of objects
Exactly.
that share some things, but also have their own little specializations.
Exactly. They're connected but distinct.
I'm really starting to see how these 4 pillars work together.
They do. They work together beautifully.
And, this is just the beginning, right?
Yeah, right. This is just the foundation.
Okay.
There's a whole universe of design patterns, best practices,
Oh, I imagine.
Specific techniques that build on these 4 principles
Oh, wow.
to help developers create even more complex and even more sophisticated software.
That's a lot to take in. But it's really fascinating to see how something seemingly so simple
Yeah.
can lead to such powerful results.
It is. It's all about building blocks, building on those simple concepts.
Yeah, that's true. Now, are there ever situations where OOP might not be the best way to go?
That's a great question, and it's one that every developer should be asking themselves at the start of a new project.
Yeah.
Because, OP is powerful,
Right.
but it's not always the right tool for the job.
When should I put down the OOP hammer?
Well, for example, if you're dealing with a very small, straightforward project,
Okay.
using OOP might just add a lot of unnecessary complexity,
Right.
and a lot of overhead.
So it's all about scale.
It is.
If it's a simple project, you don't need to bring in all that complexity.
Exactly. It's like using a bulldozer to dig a little hole for a tiny seedling.
That's a good one. Yeah.
Sometimes a simple, straightforward procedural approach
Yeah.
is more than enough to get the job done.
And even within a bigger project, right,
Well,
there might be some parts that are better suited to that more procedural approach.
Exactly. It's
Oh,
all about choosing the right tool for the job. And remember that language you mentioned, PowerBASIC.
Yes.
It was actually designed for that.
It can do both.
It could do both. It allows you to blend the OOP and the procedural
That's good.
within the same project, right?
Yeah,
That kind of flexibility can be very, very helpful.
for sure.
Because in the real world, things are rarely black and white.
That's true.
Sometimes you need a little bit of both.
Okay, so there's no magic formula for when to use OOP.
No, there is no magic formula.
It's all about thinking it through.
It is.
Considering your team, the project,
Absolutely.
are there other things to think about when deciding whether or not to use OOP?
Yeah, for sure. The skills and experience of your team
Right.
are a crucial factor. If you've got a team that's completely new to OOP,
Yeah, we talked about that learning curve.
that learning curve can be steep. And you have to be willing to invest the time and the resources into training
Makes sense.
to make sure everyone is comfortable with it.
You don't want to just throw them into the deep end.
No. You don't want to do that.
Oh.
And even if your team has some experience with OP,
Right.
you still need to think about the challenges of the project, right?
Yeah.
Because some projects are just naturally more suited to an OOP approach than others.
Okay, so it's a lot of different variables to consider.
It is. There's no one-size-fits-all answer, which is, that's what makes software development so interesting.
Yeah, that's true.
It's not just about writing code. It's about making those informed decisions,
Right.
understanding the trade-offs and choosing the right approach.
Awesome. I'm really starting to understand OOP now and how it fits into the big picture of software development. This has been a fantastic exploration of OP.
Yeah.
We've gone from those 4 fundamental pillars
Yeah.
to the pros, the cons, and all those important things to consider.
As decision points.
The decision points, yeah. So listener, think about those before you start your next project. The world of software development is always changing.
It is.
And
Back.
OP is just one approach, one way of doing things.
One tool in the toolbox.
That's a great way to put it.
What matters most is that you keep learning. You keep experimenting.
Yeah, keep exploring.
Keep exploring and find what works for you.
Awesome. Well, that brings us to the end of our deep dive into object-oriented programming.
It does.
We really hope this has given you a solid foundation.
Yeah.
Maybe spark some curiosity.
Sure.
And as always, happy coding.